You have likely heard the narrative that Boston Dynamics leadership recently highlighted a critical data gap between isolated tasks and full deployment. You are here because you want to know what that actually means for the future of robotics. The real stakes involve whether the bottleneck is the intelligence of the machines or the impossible cost of teaching them to handle the real world. By the end of this explanation, you will understand why the industry is pivoting away from pure algorithmic novelty and toward the brutal economics of data collection. For years, the robotics community operated under a seductive assumption. The logic was simple. If we can make the artificial intelligence smarter, the robots will become autonomous. We saw this in the early days of Boston Dynamics, where the focus was entirely on the software stack. The behavior tree libraries and the Spot SDK were designed to make the robots more capable. The prevailing belief was that once the neural networks reached a certain threshold of complexity, the machines would just figure out the rest. The hardware would follow the software. This is the myth that has kept many engineering teams stuck in a loop of endless research and zero deployment. Here is the thing that changes everything. The bottleneck is not the intelligence of the model. It is not a lack of compute power or a missing algorithmic breakthrough. The bottleneck is the last mile of real-world variance. In a simulation, you can generate infinite scenarios. You can create millions of virtual days where the robot walks across a perfect floor. But the real world does not offer infinite perfect days. It offers a chaotic mix of mud, oil, uneven terrain, and unpredictable human interference. The gap between the simulation and the street is where the intelligence fails, not because the AI is dumb, but because it has never seen the specific failure mode required to handle that situation. Quick resource note. I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Consider the difference between training a model on a curated dataset versus a real-world deployment. When you train a robot to pick up an object, you can simulate that action thousands of times. The AI learns the physics of the grasp. But in the real world, the object might be slightly deformed, covered in grease, or placed on a surface that vibrates. The AI does not hallucinate a solution. It simply encounters a distribution of data it has never seen during training. This is the data gap. It is the distance between the clean, controlled environment of a lab and the messy, unstructured reality of a factory floor. The cost of closing this gap is where the engineering reality sets in. To make a robot robust enough for full deployment, you need to collect millions of examples of these rare failure modes. You need to capture every way the robot can slip, trip, or drop an item. This requires a massive infrastructure of data collection. You cannot rely on generic simulators because they cannot model the friction of wet concrete or the specific texture of a worn tire. You need custom, domain-specific pipelines to capture these physical interactions. The cost of building these pipelines is exponential. It is not just about writing code, it is about deploying robots to the field, recording their failures, and then retraining the models. This creates a fundamental trade-off for engineering teams. They face a choice between end-to-end neural policies and brittle behavior trees. End-to-end policies are elegant. They promise that the robot will learn to handle any situation through a single neural network. But to make them work, you need the massive dataset of real-world variance that is currently prohibitive to collect. Because of this cost, teams are forced to rely on rule-based fallbacks and behavior trees. These are the packages found in the Spot SDK and open-source repositories. They are not the most intelligent solution, but they are the most reliable one, because they are explicitly programmed to handle known edge cases. The industry is not waiting for the AI to get smarter. It is waiting for the data infrastructure to become cheaper and more efficient. This realization shifts the entire career landscape for robotics professionals. The industry is moving away from hiring pure AI researchers who focus solely on model architecture. The new demand is for data-centric engineers. These are the people who specialize in building the data flywheel. They automate the collection, labeling, and retraining loops for real-world variance. They understand that the value of a robot is not in its neural network size, but in the breadth of its training data. The person who can build the pipeline to capture rare physical interactions is now more valuable than the person who can design a new transformer architecture. This is the actual bottleneck preventing full deployment of advanced robotics. The transition from research prototypes to production-ready autonomy reveals that the primary constraint is the data collection infrastructure itself. We are seeing this in the shift from specialized training to the need for massive, heterogeneous real-world variance. The failure modes in current deployments are rarely due to the AI hallucinating a solution. They stem from the inability to generalize learned behaviors to unmodeled environmental perturbations. The intelligence gap is a myth. The data coverage gap is the reality. Until we can solve the economics of collecting diverse failure modes, the gap between tasks and full deployment will remain. The path forward requires a change in how we approach the problem. We must stop treating data collection as an afterthought and start treating it as the core engineering challenge. The next generation of roboticists will not be defined by how many layers of neural network they can stack. They will be defined by how efficiently they can build the systems that feed the AI with the diverse, high-quality data it needs to survive in the real world. The future of robotics is not in the brain, it is in the pipeline. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.